So the contents of this presentation are, let's say, 5 basic steps about fundamentals, scope, and context. Definition, data, conceptual organization, general processing strategy in the GHSL system, then some notes on novelty, core methodological toolbox, and conclusions. So the GHSL fundamentals, what we are talking about basically, what is the human settlement? The abstraction we adopt in the GHSL is composed by 2 essential components, the buildings and their inhabitants. So and also important that those human settlements are not seen in the philosophical, or I mean, we can see this artistic way. It's the perspective we see buildings and their inhabitants is a spatial quantitative modeling perspective. It's important. The tradition behind this, of course, we were not inventing this approach. It's going back to regional science in the 50s or in the mid of past century, in 1950s. Geography, urban analysis, urban planning with the work of Konstantinos Doxiadis in the 70s. But this tradition is still very active with the work on the theory of cities and complex systems, for example, of Louis Bettencourt, that is basically contemporary research. So that's the tradition of masters, let's say, that we refer to when I was designing the GHSL project. Here I copied 2 important landmark words, for example, from regional science. It was introducing the word of regional science from Walter Izard, and another picture from another landmark book of Konstantinos Doxiadis in the 70s. What I want to remark here is that in those foundational work, the discussion was about understanding the logic of people moving in the space. Try to model them, understanding and predict. So the focus was on understanding the logic of people. For example, in the Walter Izard work, the people was the labor force, and then how this labor force were working in a space together with raw materials, market, etc. So it was an economistic approach, while in the Doxiadis, the focus was on human interaction inside the different driving factors, nature, anthropos, society, shares, and network. So theories, but those theories were discussing about how we can understand the logic of people moving in the space. So understanding is the keyword. Here I draw a cluster of application of science that are traditionally working around the remote sensing technology that has a core dense area related to engineering of platform, sensor, signal, and then an application periphery of science that are typically geology, hydrology, oceanography, forestry, agriculture, ecological science, atmosphere. Those science are dominating the discussion about the use of remote sensing technologies. The GHSL doesn't start from this cluster of science, but from an alternative cluster of science that we can name as a social science, including econometrics, analysis of public policies, including town regional planning, regional science, econometrics, sociology. So those science, they use already empirical data, of course, but field surveys, census, and cartography mainly. So not dominating the discussion about the remote sensing technology. So the idea of behind the GHSL was to cross-fertilize those 2 clusters of data and sciences. Important to notice again that on the left side in this cluster, the focus is on monitoring. Like the humans are behind, are let's say outside the discussion. So the humans are the one that monitors. While in this cluster of science, the humans are the focus of the discussion, and that's make a great difference between the 2 clusters of science, of course. But now we don't have time to discuss more. Then the scope and the use context of the GHSL as we were defined more than 10 years ago. So the point is that we might allow, thanks to new technology, new open data available, we might allow to produce fine scale and globally consistent measurement that focus on human settlement. I stress on the word measurements, so quantitative facts. And those quantitative facts, those measurements can be essential for international comparability and to support public decision making. So the two core important things are measurement and support public decision metric. Those are the reference to let's say, go more in detail about those principles. But I want to just mention the fact that when we say evidence-based policy action, we postulate basically that there is such a kind that we can call public interest or public good. That's a postulation. There are school of thinking that they claim that this is an invention, for example. Is not existing, but behind the GHSL there is such a postulation. So the GHSL project makes sense if we can postulate that there is a public interest. So it's made around this concept very much. And also it's important that inside the evidence-based policy action, there is the need to have a simple and easily interpretable assumption that allow people to discuss about the model. So the postulation here is that the models are tools for human learning, facilitating human discussion. So you see, it's another perspective respect to the hard science, let's say. So in the social science, the models are tools helping human to learn. So the focus is in the human learning, not in the machine learning. You see what is the difference. And then if it's a good model, then it should facilitate the human discussion and then not imposing a given machine-driven solution. That's an important aspect of the GHSL at the high-level theoretical or philosophical point. Another point important is the full repeatability of the measure that we inherit from the National Institute for Standard Technology, the guidelines on evaluation. The uncertainty on measurement, but we will go back later on that. So those are the scope and context. If we zoom in the evidence-based policy action, then we have the stress of the, let's say, the importance of the GHSL to work in an open data and methods ecosystem. So we work in the open data method ecosystem because we aim to have an evidence-based policy action. So theoretically, if you want to have evidence-based policy action, then you might go inside an open data and methods ecosystem. So we adhere to the fair data principle that is listed there. We were very happy to work in the frame of a full and open data sharing principle of the Earth observation, the group of Earth observation, and also we naturally, let's say, adopt the directive of the European Union on the open data and reuse of public sector information. So for us, it's not a problem because it was already designed like that, the project at the beginning. Then a little zoom on repeatability. So for us, not for us, let's say the notion of repeatability of measurement that we adopt, as I said, is the one of NIST, and is the ability to repeat the measurement made on the same subject under identical condition and shall be distinguished by from the reproducibility of the experiment concept that is common in scientific literature. We can talk hours about that, but the point is that for us, let's say in our project, we prefer to use inferential system that always produce the exact same measurement. For example, the exact same built-up surface estimates if we provide the same image and the same training setting input. This property is by construction not fully satisfied by classification methods that require stochastic iterative processes for convergence to a given inferential solution. And so this is also a point of a difference between the GHSL and other projects that might use artificial intelligence or machine learning, but they don't have this constraint, let's say. This is a slide about the definition. I will not go through all these points, but the message here behind this slide is that let's say we were working a lot in the GHSL to make semantic transparency of what we talk about. So if we talk about the buildings, we try to define what is a building, what is a residential area, built surface. Our understanding is that this transparency facilitates, again, human discussion and about the model prediction, and also facilitate the validation of the model prediction. If you are clear and transparent what you aim to predict, for example, built-up surface, then it will be easier to validate versus observed data, for example. The data conceptual organization, we are the step 3 of the GHSL. It's quite peculiar. We call that a hierarchical multiple abstraction meta model for spatial information production. And it's not, as you can see, it's made by different layers at different resolution. The resolution is going from 10 meters to 1 kilometer, but those different information layers are organized from low abstraction level to high abstraction level, and there is a relation between the resolution of the data, of the spatial data, and the abstraction level. More you are abstract, and bigger is the sample of the spatial data that it's say discussing about this higher level abstraction. It's also important to say that at the lower level, you have information directly inferred from remote sensing data. In the mid part of this pyramid, you have the area where we integrate the different sources. In the GHSL release 2023, it is 100-meter resolution, this level. And this is a crucial level where we merge the information coming from sensor and the information coming from census data, for example, but also other sensors like the historical Landsat data, etc. So that's the integration part of the system, and then you have the high abstraction level layer, like the degree of harmonization that will be discussed later. This is the ecosystem of information related to the GHSL. Again, I will not go point by point, but the message behind this slide is that GHSL is not just one layer. It's an ecosystem of information, or spatial information, that it's interconnected, and it is integrated in the best way using artificial intelligence and statistical methodologies. So the value added of the GHSL is not only in the single layer. You will see there is a value added in the single layer also, but it's also mainly in the fact that those layers are coming from different sources that are integrated together in a systematic ecosystem of information. The general processing strategy that we were adopting to solve the problem of the production of the release 2023, it's summarized here. We have Sentinel-2 data, composite data of the year 2018 at 10-meter resolution, and prior knowledge. Those two main things, they generate a base layer for 2018 at 10-meter resolution or at 100-meter resolution regarding the building height, the water. It's at 10 meter, the built-up surface is at 10 meter, and then the non-residential functional discrimination is also at 10-meter resolution. So those are base layers that then they are multiplied by the temporal factor we extract from the set of Landsat data that are going back to 1975. We extract a temporal factor and we multiply this static set of data by the temporal factor, and we make the multi-temporal built-up surface that then are used to as input for the multi-temporal population grid and the degree of urbanization grid. The novelty of primacy list of the GHSL is listed here, the most important point. The GHSL was the first global multi-temporal assessment of built-up surface at the geometric resolution. This was the origin of the GHSL project 10 years ago. We were generating this. We were the first one. And then today, the release 2023 is the first multi-temporal multi-platform integrating Sentinel-2 and historical Landsat data. So we demonstrated this that was considered as an impossible task to mix two high-resolution, let's say, land cover products from two high-resolution sensors, very different. We made the first global assessment of building high from 10-meter resolution Sentinel-2 data. We made the first global assessment of non-residential built-up surface. Actually, we were inventing this at the global level in this release. It's the first time in human history we have such data. We made the first global 10-meter resolution sub-pixel built-up surface assessment, the first global 10-meter resolution sub-pixel water surface assessment, the first global assessment of building typology, and the first, last but not least, globally internationally accepted urban-rural classification schema that we will mention it as a degree of urbanization model in this presentation. So a long list of novelty. You will also learn we are also good in prediction of those variables, but what is the core toolbox to get the work done? Basically, the core toolbox is listed here, is made by multi-scale morphological and textural filtering, symbolic machine learning, and univariate multiple objective linear regression, univariate linear disseminate mapping, and ensemble modeling. You see, I recall here the concept we were discussing before: evidence-based policy action, simple, easily interpretable assumption, human discussability of the model logic, and full repeatability of the measure. Those methods ensure you are fitting with those, let's say, theoretical requirements. In this small box on the left, basically, I say the message that in this production, in this novelty of the GHSL, we don't use inferential system that use random iterative search of inferential solution in over-parameterized discriminant function, like, for example, done in support vector machine, random forest, or artificial neural networks. So those methods are not used extensively in the GHSL data production. And so basically, the fact that we have a GHSL introducing novel information, but not using this, let's say, fashion machine learning approach, it's an evidence that basically is the narrative that if you have a complex data and then you need the complex algorithm to extract the information is false in our case. So we generated good data from a complex data landscape, but using, let's say, old-fashioned, let's say, machine learning approach, so well established. This is a zoom on the symbolic machine learning concept that is important in our information production system. The two basic steps, I mean, this is an idea of 10 years ago. Again, it's not invented yesterday, but still not very much used in the remote sensing community. But the two basic steps are very simple. We compare the new data with the existing semantic, for example, spot data 2.5 meters with the Korean land cover at 100 meters. We compare those two things. We extract a set of rules. We discover rules linking this data with this semantic, we apply the rules to this data again, and we get a new semantic, for example, a new length cover. This is an image extracted from this paper. So again, it's not something that we discovered magically now. It's something that in the community should be known since 10 years ago. And this is the basic mechanism that allow us to make a self-evolutionary GHSL production system. So the semantic available at the time zero are used to generate rules that are applied to the data at the level 1, etc., etc. And this was the mechanism allowing us to evolve from the MODIS 500-meter resolution urban Boolean definition to what we are, for example, producing from Landsat in 2016, and then what we are proposing now using Sentinel-2 data in the release 2023. So a self-evolutionary system that was allowing us to distillate better and better information from new data coming in. This is the same method, the same concept, but talking about water, because the evolutionary system, the work of the SML is not only for making built-up area classification. Of course, for example, in this case, it can be used to extract the water surface information. This is the learning set of Landsat data classified that was available. This is the Sentinel-2 data. If you discover the rules translating this data in this semantic, and then you apply those rules to this data again, you extract this new semantic. That's again the same mechanism we were discussing before related to built-up areas. Then some conclusion. We were illustrating some theoretical and methodological background related to GHSL. We were listing the multifaceted novelty landscape of the GHSL. Of course, it would be too ambitious to discuss about all aspects in the short time available, but you are lucky you have some more details on the population spatial distribution and quality control in the next two presentations. More humbly, the main purpose of this presentation was to tease your curiosity and inspiration. So please make your own explorative path in the paper that is listed here. We will be happy to answer to your question. And with this, I thank you very much for your kind attention.